Hello, my name is Emmeline, and tonight I'm going to be doing an experiment that calculates the speed of light using marshmallows. Now, what is required of doing this experiment for my extra credit in chemistry is a microwave oven, a microwave safe dish, a bag of marshmallows, and a ruler, which are all the things that I have right here. Then, with your microwave, like with mine, it has a turntable. What is recommended is that you remove the turntable because you cannot have any mechanical motion or rotating mirror in your microwave in order to do this experiment. So you first open the marshmallows, and you first open the marshmallows and then you place them on the dish, completely covering it with the layer 1 marshmallow thick. Next thing you do, so in this case I have done that, next thing you do is I'm going to remove my turntable like I advised in the beginning. So this thing is coming off. Then you put like a plate or something to ensure that you're not getting any rotation. In this case I just put a rack, a microwave safe rack, and then I put my marshmallows in here, as you see. Then I close my microwave and I put it on. Let's try 20-30 seconds. Microwave is pretty powerful. During that time, I'm looking in to check my melted portions of the marshmallow, and we're looking for melted patterns and some unmelted patterns. And what we'll do after that is, since microwaves do not cook evenly and the marshmallows will begin to melt at the hottest spots on the microwave, I heat the marshmallows until they begin to melt in 4 or 5 different spots. Now, as you'll see, my marshmallows, some are melted, some are not. Yeah, you can see that. It's hard to see with the white. I tried to do white against black, but this is what happened here. So, let me close the microwave. So now I'm going to go ahead and, since I removed the dish, I'm going to take my ruler and measure the distance between the melted spots. Now what I'm noticing in this pattern is that the area kind of repeats between the melted spots. It repeats over and over. And this distance will correspond to the wavelength of the microwave. So I'm going to take my ruler, which you can see here, and it's actually in millimeters. So I know I'm going to have to convert. My 1 centimeter equals 10 millimeters. So I'm looking at it and I'm measuring it here. So we're looking at approximately from here to here, and from here to there. Get that? So we're looking at about, between the melted and unmelted spots, about 6 centimeters. Right? So about 6 centimeters. So my millimeters, we're talking about 60 millimeters, total of 60 millimeters to correspond to that. Now with this done, I'm going to go ahead and put my marshmallows on the side. And I use mini marshmallows. You can use any size marshmallows you want. Now what I've done is I've kind of done my calculations on a whiteboard. And we know that speed of light is equal to frequency times wavelength. And in this case, I'm using the frequency on my microwave oven. Let me see if you can see that. I don't know if you can or not. It's hard to zoom in for you to see it. Anyway, so I'm going to use that frequency, which is 2,450 megahertz. Then I'm going to take my 6 centimeters and multiply it by 2 because remember the distance will correspond to half the wavelength of the microwave, which we said was 6 centimeters. So we multiply it by 2, so we have 12. And our 12 centimeters for wavelength will equate to 0.122 meters. So then we know that our calculations will be quite simply the 2,450 megahertz times the 0.122 meters, and that gives us a speed of light of 2.99 times 10 to the 8th meters per second. Now, that would be the calculation for speed of light. It's really that simple to do. And what I did additionally was I decided to calculate my percent error, which was sort of silly. So I took my actual, what I got in the lab, which was 2.99 times 10 to the 8th, subtracted it from the book value, which is 2.99 times 10 to the 8th, and then I divided, then I multiplied by 100, and I get a 0% error. So, which tells me that I did this correct, and the speed of light, there was no differentiation between my lab results and the text results. So my overall speed of light calculation equated to 2.99 times 10 to the 8th. So that is it for that particular portion demonstration of my lab.